Going on to topic 7 now of chapter or module 1, we're going to give you some background information, and we'd like you to take these notes right on that page. Now, in mathematics, when we see the word intersection, it has a special word associated to it, and that word is and. So if they're talking about something and they use the word and, that is an intersection. Now the symbol for an intersection is sort of like an upside down U here. We'll see it down below, and that would be the symbol for intersection, again the word and. So you can write that right there. Now the special word union in mathematics, the key word for union is the word or, and the symbol for it is sort of a U. Now we're also going to deal with compound inequalities. While we're on intersection and union, let's look at what is called a Venn diagram. You may recall these from high school, where you have, let's say, one circle. This line didn't come out too well here, but this is set A. In this particular set of numbers, the numbers are 1, 2, 3, 4, and 5. They are in set A. Now, set B contains the numbers 4, 5, 6, 7, 8. And as you can see in this area, some of the numbers are included in both sets, that is 4 and 5. Well, if we said what is the intersection of set A and set B, the intersection, again, we would use this symbol, is the numbers, and we could put that in roster notation, 4, 5. Now, if we said the union of this set using this symbol, then it would include all of the numbers, 1 through 8. Okay? So a little use of a Venn diagram to illustrate intersections and union. Now another thing we're going to be doing in this section, and this is very important to include in your notes, are these 4 inequality expressions and 4 number lines. Now the number we're interested in all of these is 2. So I'll put that by each one. But when we are asked to graph these inequalities on a number line, there's a certain symbolism involved. And that's what I want to show you here. So if we had the inequality x is less than 2, 2 is not included in the set. And we indicate that by using a parenthesis facing left and then darkening the arrow. So this is the graph of this inequality. 2x is less than 2. Now, for this one, x is less than or equal to 2. The only change, instead of using a parenthesis, we're going to use a bracket. Again, facing left and darkening the line and enlarging the arrow. Now in this one, 2 is x is greater than 2, but 2 is not included. So again, we use a parenthesis facing right and then darkening it. And for this one, x is greater than or equal to 2. We're going to use a bracket. So again, important reference for your notes. Now, while we're here and we have the graph of these inequalities, I'm also going to write this in interval notation. So we can take interval notation right from the graph. Where is this coming from? Negative infinity. And it goes up to 2, but 2 is not included. And this one, it's coming from negative infinity. And infinity always has a parenthesis. But this time, 2 is included in the set, so we use a bracket. Now, this one is starting just beyond 2. 2 is not included, so we put a 2 there. And it goes to positive infinity. And this one, it's starting at 2. 2 is included, so we use a bracket. And then to positive infinity. Infinity always has a parenthesis. So excellent reference for as we do the examples to follow. And this should be in your notes. So in example 1, we're going to look at the intersection of these two sets of numbers. Now again, there's the sign for intersection, and if we had the word, it would be and. And we'll use roster notation. Now 3 is not in both. 5, no. 7, no. 8, no. Now 9 is found in both. And the other one found in both is 11. So in this, we're going to put 9, 11. That is the intersection of these two sets of numbers. Now, here we're getting already into what is called a compound inequality. It's not just 1, but 2. So a way to write this would have been negative 2 is less than x, and x is less than 7. So how do we put that on this graph? Well, we put a line where negative 2 is, and for some of these in MATLAB, they're going to give you multiple choice. So what do we put at negative 2? A bracket or a parenthesis? In fact, for both of these. And the answer is going to be a parenthesis for both of them. And it's going to look like so. So we solved it, in a sense. It's already solved. We just had to graph it. And interval notation would be negative 2, 7. Again, the parentheses indicate that these numbers are not included in the set. Now, as we look at letter C, the numbers we're interested in, we don't know yet, because we haven't solved for x. So what is the technique to solve or isolate the x in the middle? Well, the first thing we have to do is subtract 1 from there, subtract 1 from there, and subtract 1 from there. And I'll write it over here. So this will give us 6 is less than 3x. Here the ones cancel out, and is less than 14. So we're subtracting 1 here, subtracting 1 there. Now to get the x by itself, what we do is we divide everything by what is with the x, which is a 3. So this will become 2 is less than or equal to x is less than 14/3. And the nice thing about the way I'm going to do it, we just put a line there and say that's where 2 is, and a line here, that's where 14/3 is. Remember, 15/3 would be 5, so 5 would just be after that. But what symbol do we put here? And if you said a bracket, you are correct, because 2 is included in the set. And you bring it up to 14/3, and we're going to use a parenthesis that goes like so. Now in interval notation, right from the graph, bracket 2, comma, 14/3 parenthesis. Okay, we'll go on. Now, part of what I'm showing here is how to do these examples. Now we know this is an AND, so this will be an intersection, but we want to first solve this inequality. And we solve it just like an equation. We're going to transpose the -4 to the other side where it becomes a +4, and this then becomes x is greater than 10. So we've solved this part just by transposing, and that's a -10. Yes, glad I caught that. Now here we're going to transpose this, and we get 2x is greater than or equal to a -22. So this +25 on this side becomes a -25 plus 3 gives you a -22. Now to get x by itself, we just divide both sides by 2. Now since we're dividing by a positive, we don't have to worry about changing the direction of that inequality sign. So this becomes a -11. Now we have two things that we have to plot on our number line. A -11, which will be about there, and a -10, which would be about there. Now this says x is greater than or equal to -11. So theoretically I would put a bracket at 11 and then the line going this way. But because this is an intersection, I only put where the lines, in a sense, go on top of each other or intersect. Now here, this is x is greater than -10. So at this point, I'll change colors. We're going to put a parenthesis and a line going this way. Now here, they're not intersecting. This point right here, they're not intersecting. They only start intersecting at this point. And because of this is an AND, an intersection, our answer is just this part. This would be the answer to this part, where they intersect. So again, make careful notes. Write anything else you want to include what I've just explained. You want the point of intersection, where these two lines intersect, go over each other. All right, this is also an AND. So we do this one the same way. We have 3x is less than, I'm going to transpose this -1 to the other side, where it becomes a +1, so this gives me a -3. Divide both sides by 3, I get x is less than -1. So I've solved this part. Now let's do this. 5x is greater than. Now over here, when we transpose, the positive 12 becomes a negative 12. So this is going to be a 5 here. Transposing from this side makes it a negative 12 on that side. Adding these together, I get this. Now I divide both sides by 5, and I get x is greater than 1. Again, this is an intersection. I have to put both of these on a graph. So one value is a negative 1, and one value is, let me do that, a positive 1 right there. Now, what sign do I put here? It says x is less than a negative 1. So I would kind of do it this way. And this one is x is greater than 1. I would have something go this way. Now, is there an intersection of these two lines? And the answer is no. In fact, the key word to describe this is a disjunction. They are separated and there's no connection. So for something like this, we're going to say it's an empty set, that is a 0 with a slash through it, or just a set of brackets with nothing inside. There is no solution for this that is an intersection. And we found that out by solving each of the inequalities, graphing them, and since there was no intersection, there is no answer for that. And again, you can come back to this, watch it again, and review the explanation. All right, we're going on to number 2. Now in number 2, they're featuring it quite well by saying union and also showing the sign for union. So find the union. Well, you set up braces and just list all the elements. 4, 6, 8. Now 8 is repeated, so we don't write it again. 9 and 10. So in MATLAB, that's how you would do it. Write them out, separate the answers by commas, and if something's repeated, you don't. But now this is a union, including all members of both sets. Now we're asked to graph, and again, this is a union, or the symbol for union is this. So these are already done, so I don't have to do much solving. I'm just going to put lines. One is 7 and one is 4. So we'll put the 7 there and the 4 there. Now it says we may want to write it a little differently here. We're saying x is greater. Be careful of that. So x is greater than 7. You can write it this way. And this one is x is less than 4. So greater than 7, and 7's not included, so we use a parenthesis and an arrow going this way. And here we're saying x is less than 4, parenthesis going this way, and an arrow thickening. Now here, this is a disjunction, and that's fine because this is an or. That is a union. If it were an intersection, there would be no answer. But in a union, this is the answer. Now, how do I write this in interval notation? Well, here's where it comes in, so watch it carefully. This is coming from negative infinity, going up to 4, so comma 4, and what symbol? A parenthesis. And since we're joining these, we're going to use the union symbol, and it goes parenthesis on this side, starting at 7. 7 is not included in the set, and goes to positive infinity. Okay, let's do this one, and I'll change color. We want to solve this. So this is 2x. I'm going to transpose the 5 to the other side. That becomes a negative 5, so is less than or equal to negative 12. This on the other side is a negative 5 plus 7, negative 12. Or, I guess I can finish this side, divide both sides by 2. I get x is less than or equal to negative 6. All right, now here's a case where we have a negative, and eventually we're going to have to reverse the sign. Now, one way of doing it would be just to take this term, put it to the other side, but I'll leave it this way. So we're going to have a negative 6x is less than or equal to. Now on this side, the 12, as we transpose it, becomes a negative 12, and a 4, and an 8, I should say, gives us a negative 4. So once again, this stays the same right now. I'm going to transpose this to the other side where it becomes a negative 12. 8 minus 12 is negative 4. Now here's where I have to reverse the inequality, because I'm going to divide by a negative 6. Divide this by a negative 6. When I do that, this inequality sign changes its direction, and I get x. A positive x is less than or equal to a positive 2/3. Okay, so here are my two inequalities, and I'm going to plot a negative 6 here, and I'm going to plot a 2/3, which will be about there. Now as I plot this, x is less than or equal to negative 6, I'm going to use a bracket. Darken this and put in my little arrow. Now this one, x is greater than or equal to this. I'm going to use a bracket facing this direction. And again, this is a disjunction. And it's okay because this is an or, a union. Now, in interval notation, once again, this would be coming from negative infinity up to negative 6, bracket, right from the graph, the union symbol, starting at 2/3 here, and positive infinity. So study this, get some notes, and if anyone has a question, of course, ask. And let me stress this part one more time. When we have a negative 6x, we want our x to be positive, so we're dividing an inequality by a negative. In order to keep this true, we have to reverse the direction of our inequality sign. A very important thing. Now in these next few, let me work them out for you. And these are OR, so they're union. And again, I could reverse the direction of the inequality by just taking this negative 3x and moving that to the other side. So this now becomes 3x. I'm going to move this to the other side as a negative 6. Well, negative 5 and negative 1, negative 6. Now I'm going to divide by a positive. Dividing by a positive, I don't have to change the direction. So this will become x, and this is a negative 2. Now, most people don't want to read it this way, so I'm going to rewrite it so it's x on the left. Notice the wide opening is toward the x. I'm just reading it in a sense from right to left. So that's that part. And this part will be x is less than. Now when I bring a negative 6 to the other side, it becomes a positive 6. So this becomes a negative 7. Now notice this inequality will be a bracket. This inequality sign would be a parenthesis. So I have a negative 2 here. And I have a negative 7. So let me do that one again here. Let's put the negative 7 there. And we'll put the negative 2 there. That's better. Now this says x is greater than or equal to negative 2. So we put a bracket. And it goes this way. Some people have asked, a hint is, you see the direction of our inequality sign? That's the direction of the arrow that we're following here. Now this is x is less than negative 7. So here we're going to use a parenthesis and this way. An interval notation, negative infinity, right from the graph, comma, negative 7 parenthesis, union symbol, bracket, negative 2, infinity. All right, let's do this one here now. We have 4x is less than or equal to, we're going to transpose the negative 12. On this side it becomes a positive 12. Minus 8 is 4. Divide both sides by 4. X is less than or equal to 1. Now here we have 5x is greater than, there's no equal symbol there, so transpose that, that's going to be a negative 5. Well, the negative 7 plus 2 gives me a negative 5. Divide both sides by 5, x is greater than negative 1. So we have here a negative 1, and here we have a positive 1. Now here we're going to have a inequality symbol that also includes equal, so we have to have a bracket. It's going to go in this direction. And here we have x is greater than negative 1. We have a parenthesis that goes in this direction. Now if we were dealing with an intersection, this would be our intersection, but we're dealing with a union. So the whole line then becomes darkened and arrows at both ends. So what would be interval notation of this? Well, it would be from negative infinity to positive infinity. That is all real numbers. So again, they're giving us a few of many different kinds in which we use the skills that we're taking notes on, studying, and hopefully mastering. Now, as we look at this next one, they're asking us to use interval notation to write the domain of this function. Now, let's take a look at this function here, what they're asking us. We have x minus 3. Well, in order for this to be a real number, what we have under the radical sign has to be equal to 0 or greater than 0. So to solve this, we have to find what values of x under the radical sign would make it a negative number, that is, less than 0. So we do so by saying x minus 3 is greater or equal to 0. So we get, this is an easy one, x is greater or equal to 3. Now, if x were 2, let's say, 2 minus 3 would make under the radical sign a negative 1. Well, real numbers, you can't have a negative value under the radical sign. Those numbers are not real numbers. So, again, we're saying the lowest it could possibly be is 0, which is what we've set up. X minus 3 is greater or equal to 0. And that gives us this as an answer. So if we were to graph that, the number we're interested in is 3, and this would be a bracket, and it would look like so. Now, they're not asking us to graph it, but they are asking us to put it in interval notation. So this would be a bracket. We would put a 3 there, and then to positive infinity. And we figured it out again by saying you can't have a value that is less than 0 under the radical, because those numbers are not real numbers. Now, in letter B, we have 2 radical signs, and a plus is translated here as an and. So, what we do, that same technique, we go 3x plus 1 is greater or equal to 0, and x minus 1 is greater or equal to 0. So in this case, we would have, we transpose the 1, that becomes a negative 1 on that side, and we're going to divide both sides by 3. So x is greater than or equal to a negative 1/3. And on a number line, a negative 1/3 is right there. And we can also put in a bracket there in a sense. And it kind of goes in this direction. But now we have to do this one. So here it's easy. X is greater than or equal to 1. Now 1 on the number line is right there. And what symbol do we put there? Well, we put a bracket. Now, here's the key to all this. What kind of relationship are we showing here when we have a plus and we have the word and? And the answer is it's an intersection. So the answer to this would be, where do these red and blue lines overlap? It overlaps right there. So interval notation would be from a positive 1, and 1 is included in the set, and it goes to positive infinity. And that's the answer, and this is how we found it out. So part of this is to understand this function notation, noticing they want intersection, putting each of what is under the radical sign greater or equal to 0, solving it, putting it on a number line if you'd like to graph it, but you're looking for the N, the intersection. That would be the answer to letter B. Okay, that wraps this up. We'll do our last topic of Chapter 1 coming up soon.